Good afternoon and welcome to this webinar, MicroGroove Copper Tube Coils, Moving Beyond Residential Applications. This event, brought to you by the ACHR News and Appliance Design, is sponsored by MicroGroove. I'm your moderator, Kyle Gregaro, Editor-in-Chief of the ACHR News. Thanks for joining us. Today's presenters are John Hipschen and Matt Holland. John has over 16 years of experience with heat exchanger technologies, including the marketing of copper alloys as well as manufacturing technologies for brazing and soldering. Previously, he managed the development of new markets for specialized equipment systems. John graduated from Loyola University in Chicago, he might be a Blackhawk fan, and spent his early career working as a chemist. Matt Holland is Vice President of Operations for the Richmond division of Super Radiator Coils. The division is home to the industry-leading wind tunnel test lab where the MicroGroove coils presented in this webinar were developed. Super Radiator Coils is a full-service engineering and manufacturing company offering heat transfer coils to a wide array of commercial and industrial markets. However, before we begin the presentation, I want to provide you with a few housekeeping items. At the bottom of your screen, you will see a taskbar. Each icon on the taskbar is assigned to a particular element of today's webinar. If you're unsure about what an icon does, just hover over the icon with your mouse and a box will pop up that tells you the function. The quiz and a copy of today's presentation are located in the handouts icon. Please take our survey following the webinar by clicking on the survey icon in the taskbar. Below the presenter photo, there is a blank question box that allows you to type a question in the box and then hit submit to send it to us. Later in this live program, our presenters will address as many questions as possible. Today's event is being recorded and archived on achrnews.com. All registered participants will receive an email within 1 or 2 business days that has a link to view a recording of this event. But now, I'm excited to turn this over to our first presenter today. John, why don't you take the reins?
Thanks, Kyle. Appreciate it. And you're right, I am a Blackhawks fan, as is just about everybody in Chicago right now. On behalf of the International Copper Association and the Copper Alliance, I want to welcome everybody to this webinar. The Copper Alliance represents a large network of copper centers around the world, and our mission is to make sure the market's aware of the benefits of copper, as well as the latest advancements in technology and market developments. And in the world of air conditioning and refrigeration, the Copper Alliance has been actively promoting the trend toward MicroGroove copper tubes. Today, our webinar will briefly review MicroGroove technology, and we'll show why that trend continues. We'll then take more time to show how small diameter copper tubes have moved into larger commercial and industrial applications. You'll notice that the driving force behind all of this movement is increased performance, which translates into energy efficiency. And big leaps in efficiency offer us important options that were not available in the past. Today, you'll see how these options are helping commercial and industrial coils become more compact and cost efficient. Oops, a little too far. Before we go further, I want to point out an important resource. At microgroove.net, you'll find a wealth of information, including technical papers, news releases, and you'll also find archived webinars that were presented over the past couple of years. And in fact, today's webinar will be archived at microgroove.net. It'll probably be there in a week or two. The first couple of webinars focused primarily on technology, and we went into quite a bit of detail describing the benefits of MicroGroove tubes. We then presented a webinar last year in partnership with Burr Oak Tool Company, and that delved into the equipment needed to make coils from smaller diameter MicroGroove tubes. Today, we're going to look closely at commercial applications with higher performance and efficiency demands. And the coils we'll be talking about are, again, round tube, flat thin coils, and they can be condensers, evaporators, or even industrial heat exchangers. And we find these coils in commercial air conditioning and air handling units that we see on top of buildings, or in commercial refrigeration like the refrigerated display cases at the local supermarket, and we see them in walk-in freezers. And these applications also include food processing and refrigerated transportation, cooling at power and energy plants, and heat exchangers for industrial processing. And because the Copper Alliance wanted to bring first-hand information from a source that's actively involved in manufacturing and supplying these high-performance commercial coils, we're extremely pleased to be presenting this webinar today in partnership with Super Radiator Coils. Super Radiator Coils has been in this business for 85 years, and using a very well-equipped testing lab and technical resources, they've developed coils with MicroGroove technology that are often saving their customers more than 50% in refrigerant charge and reducing tube and fin weights by over 40%. So before I turn this webinar over to Matt Holland from Super Radiator Coils, I want to quickly review the basics behind MicroGroove technology and discuss exactly where these efficiencies are coming from. Micro, in the word MicroGroove, refers to small diameter copper tubes. And as you can see, when we reduce tube diameters, the result is a big increase in surface area that's available to transfer heat. Groove, in the word MicroGroove, refers to enhancements that are found on the internal surface of the tubes. These enhancements are grooves or patterns that reduce boundary layers that form inside the tube. And we want to reduce or eliminate these boundary layers because they act as an insulator and they slow down the heat transfer that we really want to have happening as fast as possible. So the two main phenomena that drive the benefits of MicroGroove technology are the increased surface area that we get from smaller tube diameters and the reduction of boundary layers both inside and outside of the tubes. And the result of increased surface area and reduced boundary layers is increased heat transfer. And what that really means for us is energy efficiency and potentially big cost savings. So let's look closer at using smaller diameter copper tubes because what on the surface looks like rather simple ideas, they can have pretty dramatic improvement on a cooling system, and it can get somewhat complex when it's time to decide just how these benefits will best be applied to a specific situation. Let's take a closer look at the reduction of boundary layers. And as I mentioned, boundary layers develop both inside and outside the tube. Here we're looking at the inside of the tube. Whenever fluid moves through a tube, the fluid that's closest to the tube wall behaves differently than the fluid in the center of the tube. And that fluid next to the tube wall moves slower than the fluid at the center, and a boundary layer forms next to the tube wall where heat transfer becomes much more difficult. And even in turbulent flow, a laminar sublayer forms and heat moves slower through these boundary layers than it does in the faster moving fluid that's toward the center of the tube. We need to remember that boundary layers act as an insulator and they interfere with the heat transfer that we really want. MicroGroove tubes with internal enhancements, they reduce the formation of boundary layers. And this illustration shows how the boundary layer begins to develop, but it breaks down as it moves over the grooves. The additional mixing of the refrigerant that occurs inside the tube because of these grooves increases the amount of refrigerant that comes in contact with the tube wall. The positive effect of heat transfer from these internal enhancements has been known for a long time, and it's been also applied commercially for a long time. But what's new more recently is a combination of internal tube enhancements with small diameter tubes. Now air, being a fluid, that also forms a boundary layer on the outside of the tube, just like refrigerant forms one on the inside. But if we look at the boundary layer that forms outside of a 3/8 inch or a 9.5 millimeter tube, and we compare that to the boundary layer outside of a 5 millimeter tube, you'll see a considerable reduction in the size of the boundary layer outside of the smaller tube. And this reduction in boundary layers further improves the efficiency of the heat transfer in coils with MicroGroove tubes. As a result of the increased surface area from smaller diameter tubes, plus the reduced boundary layers, we have higher performing, more efficient heat exchangers that use less material and less refrigerant. And in a minute, we'll see how manufacturers like Super Radiator Coils can use these advantages in different ways to solve various problems that their customers come to them with. The manufacturing process for MicroGroove coils is a proven process and it's been in use for a long time. And using smaller diameter tubes does require some tooling changes and process modifications, but these changes are minimal, and manufacturers are finding themselves better positioned now to compete in a market that's always demanding more performance for less cost. At this point, we're going to start comparing coils that are made with conventional 3/8 inch or 9.5 millimeter copper tubes, and we're going to compare those coils to those made with smaller 5 millimeter tubes. And because this trend is so prevalent, we're going to continue this comparison throughout the rest of this webinar. Now, the word microgroove isn't associated with any one particular tube size. It just simply refers to the trend to downsize tubes, and we're not really sure right now where that trend is going to end up. But the economic argument behind the movement toward 5 millimeter tubes is certainly a strong one. And we can see in this information supplied by Super Radiator Coils that reductions in fin and tube weights can be as much as 50%. And the reduction in the internal volume can be even more than 50%. And that means considerably lower refrigerant charge. Smaller diameter tubes can also support pressure with thinner tube walls than the larger tubes can, and again, this leads to significant material reductions. And if we look at this pressure benefit a different way, with smaller tube diameters, we can handle much higher operating pressures with the same wall thicknesses that we had in the larger tubes. And this is particularly exciting to engineers that are working with CO2 systems. So now, having reviewed the technology basics, I want to hand this webinar over to Matt Howland from Super Radiator Coils. But keep in mind these benefits that we just discussed, because Matt will show real-life examples of how this technology and the benefits that result from it are helping the industry produce smaller, more efficient, more environmentally friendly, and less costly cooling systems. So it's my pleasure now to introduce Matt Howland from Super Radiator Coils.
Thanks, John. In just a minute, we'll be walking through a live demonstration of how we use our software selection tools to size different heat exchangers. But I wanted to just take a moment to introduce Super Radiator Coils to those who may not be familiar with us. We're a company that's been around a long time, 85 years in heat transfer. We have 3 locations in the United States with a nice manufacturing footprint. We have a regional structure because Super Radiator, at its heart, supports our OEMs. We really work closely with OEMs to develop the best components for their products. And we're excited about how MicroGroove, and particularly the 5 millimeter MicroGroove, can be applied in these applications. The title of our webinar today is Moving Beyond Residential Applications. 5 millimeter MicroGroove has been used and has a nice long history now developed in residential applications. But Super Radiator Coils, we focus and serve a more industrial and heavy commercial and some light commercial industries. And we were excited about the development of this product extending beyond that. We have 26 different fin patterns in our company, this being the 26th. And a fin pattern for us is a tube size and its orientation. So even within that, there's separate enhancements of sine wave and corrugated. And we'll show you how we've added those to the 5 millimeter as well. We have several different tube diameters, but I think what separates us as well is that we have a deep bench of applications engineers who work closely with our OEM customers to help develop the best products and help figure out if something like today's MicroGroove coil that we're talking about fits for their company. And so what's unique, I think, or counterintuitive perhaps, about the MicroGroove is that small tubes does not necessarily mean small coils. Although the original adoption was in residential, we saw application for this using, as John talked about, in much larger systems. And so as we move into commercial industrial products, we'll see a lot of applications. And we'll walk you through some of those applications here today. The product that the 5mm MicroGroove product was developed in our wind tunnel test lab here in Richmond, Virginia. We're very proud of this tool. You can see here listed, it has a deep bench of capabilities, a wide range of airflows that we can operate the test lab under. We can introduce humidity rates. We can run several different fluids through the coils that are tested in the lab. And in development of the 5mm tube product, we use both water to get the primary heat transfer coefficients, and we're able to run refrigerants to then validate those in condensing and evaporator conditions. But I think what was really unique, and John shared early on, showing the inside heat transfer perspective of the 5mm tubing. And there's a lot of research that's been done on individual tubes. It is much more difficult to capture the thin side heat transfer benefits. And it was with the lab and the work of Dr. Jin that you see pictured here that we were able to really isolate the correct pattern using sine, corrugated, enhanced, and other enhancements to the product that we've been able to incorporate into our design selection software. For those interested to learn more about the lab, you can go to our website and there's a short video. It's worth the 5 minutes to take a look at that video to see what the lab can do. I do want to just break down and elaborate a little bit more on some points that John made about the compounding benefits. And if you'll bear with me if we go back to our fundamentals of our core heat transfer coefficient, of our U value, area, and our delta T, we see this compounding benefit. And this is what got us excited about deploying this into these commercial and industrial applications. What you see is that we need less metal to achieve the same effective area. And we'll show how geometry operates in our favor. But more exciting is that we were able to validate in the lab that we see better inside and external heat transfer coefficients. So we get this multiplicable effect. Well, let's take a little closer look. Here I have, again, the basis of comparison using a traditional 3/8 copper tube coil next to its 5mm MicroGroove counterpart. And if you'll think about this as a cross-sectional area and driving our primary heat transfer surface, and if we were to sum up the circumference of each of those primary surface areas, what we'll see is in the 5mm tube, we have 40 inches or 40% more in the sum of the circumference or primary surface. But here's the really interesting point. Stay with the circumference and extend that to the cross-sectional area of that tube. And if you think about the cross-sectional area of that tube, what we found was that we need less copper to do that. We were able to, with 10% less copper, to achieve 40% more primary contact area. And that became very powerful. So then if we just run with that further to look at that compounding benefit and think about the fin efficiency, here again is our 3/8 traditional tube pattern. And we're showing this illustration here with the reduction in fin efficiency as you move proximity from the primary surface. You diminish the effectiveness of the fin in its proximity to the primary surface. So as you see that here in the color coding, and then again we compare it to our 5mm, you see the amount of additional red and orange coloration on that extended surface. We're getting a lot more work out of our extended surface by keeping it closer to that primary surface. And so this is where we see driving up the overall average coefficient use of that extended surface. A lot more work out of that fin. So, but now let's get to the exciting part about how do we put all this to work. And I'm happy to hand over the presentation now to Louis Rogerson, who's our Director of Engineering Sales here for Super Radiator Coils in Richmond. And Louis will walk you through a live demonstration of how a customer might apply this product if you're in a traditional 3/8 copper tube aluminum coil or a 1/2 inch or traditional products and you wanted to apply this, how you might do that. And he'll walk you through a live demonstration using our selection software. Louis?
Thanks, Matt.
What we're going to be looking at today are a few different scenarios of how you might integrate 5mm into your existing rooftop condensing unit. For the unit we're going to be evaluating, we're going to start with a nominal 14-ton condenser using 3/8 tube. The coil that we'll evaluate is 36 inches fin height by 60-inch fin length. Refrigerant is 134A, 95-degree ambient temperature, so that's rooftop most anywhere in North America, and we'll use a condensing temperature of 120 degrees F. So bear with me here a minute, and we're going to switch over to, you should see on your screen now, Super Radiator's screen from Super Radiator's Enterprise Coil Design software. This is an extremely flexible program that's designed to model nearly any heat transfer. So we're just verifying that you can indeed see the screen there. Let me go back and make sure that we did. Up. So let's switch over there again. Okay, great. So you should see now a screenshot of our enterprise selection software. And I've preloaded in our existing 3/8 coil. So this is our summary screen. I'll show you a different way you can look at this information a bit later. But for our application, we're going to have 10,800 CFM with the 95 dry bulb entering the coil, capacity of 196,000 BTUs per hour. That will include our heat of compression that we would experience. Because we've put both our airflow and our entering and BTU per hour in, the program automatically calculates our leaving air temperature. Refrigerant 134A. And then the condensing hot gas temperatures. These items will remain constant through the balance of the analysis. As we mentioned, we're going to start with our 3/8 tube coil. We could, if you are in an older system, we could model 1/2-inch tube as well, so you see that selection in the drop-down box. But for our initial run, we'll take a look at the 3/8 tube coil. And in traditional, we call it die 11 here in Super Radiator. It's a 1 by 0.866 staggered tube arrangement. The fin surface we'll use is sine wave. This is a non-enhanced surface. Copper tubes, 015 rifled, a very common internally enhanced rifled surface. Aluminum fins, 0055 thickness, 36 by 60 as we mentioned. We'll figure 10 fins per inch is a fairly nominal fin spacing for the coil. Cross-flow arrangement, we've input the number of circuits for the coil, and we'll come down to how many rows do we need to meet the performance we've requested. And it tells us 3.9. We have some preliminary data here, but we can't build a 3.9 row coil. Really close to 4, so we'll rate a 4-row coil. If you wanted more, you have options here as well. So let's do calculate on this coil to get a full printout of the performance. A couple of key pieces of information you want to see here is that your capacity on the coil is 198,000 BTUs per hour, air friction of 0.65 inches of water gauge, and a refrigerant pressure drop of 2.3 psi. A couple of key pieces that we'll want to understand going forward is what's the weight of the coil and the internal volume. So this coil weighs approximately 150 pounds, and the internal volume is 150 cubic inches. Of that weight, 48 pounds is in copper. So remember that, 48 pounds of copper. So the first step we want to look at is, let's take this coil, change nothing physically about the footprint of the coil, and put a 5mm coil in there. So I'll switch over to one I've preloaded for a 5mm replacement of this. So our inputs for the air side and refrigerant are the same. Change it now to the 5mm, which as Matt said is what we call number 26. As John mentioned, we're going to now go with an 010 wall thickness. Because of the smaller diameter, the thinner wall thickness is what we need for this pressure. Aluminum fins at 0039 and the same physical dimensions. Our fins per inch will go up slightly to 17, and we've input our circuiting information. So we'll analyze that, 3.85 rows. Let's rate that as a 4-row coil. So we'll click Calculate at the bottom, and we see now that our performance is actually slightly better. It's 201,000 BTUs per hour, and the air friction is considerably less at 0.45. We can compare these side by side by creating a short schedule for our 3/8 tube coil and our 5mm drop-in replacement. We'll take a look at those quickly together. And what we can see is our capacity between the two coils is very much the same as we would expect. The leaving air temperature is the same, condensing, but we've picked up a significant amount of air friction loss and the refrigerant pressure drops loss. What you don't see on the screen is the real power of the 5mm coil, and that's this. The refrigerant volume between these two coils, the 5mm coil, is 54% less than your existing 3/8 coil. That's significant. The coil weight overall is down by 32%. It's now 102 compared to 150 pounds. And the copper weight is down 53%. Same performance, less air friction, and I'm saving 53% on my copper weight. So if you just want to not change your footprint, drop-in replacement, that's one thing that we see that 5mm can do. What else might we do? Well, one of the things that some of our customers are interested in is, what if I can get the performance in less space, particularly with systems that are in cramped spaces such as mobile applications? That may be something you want to look at. So let's take a look at this. For this installation, I'm still sticking with my same performance, but now I'm going to take 18 inches off of the fin length of the coil. I'm going to shrink from 60 inches fin length down to 42 inches. And as before, we've put in the information on the materials of the coil. We'll analyze this, and because our face velocity is higher, we would expect that it's more rows. So it's 5.9 rows. So we'll analyze and calculate that as a 6-row coil. Just a quick couple of highlights here. There's the 197,000 BTUs per hour that we were looking for. Because we do have a higher face velocity, the air friction is increased. It's up to 1.4 inches. So that's something we need to consider in our design. So let's take a look at that compared to the drop-in replacement, the current 3/8. And you see a quick side-by-side comparison here. So the shorter coil at the bottom, 42-inch fin length compared to 60-inch fin length. What we've done with this coil is now we've decreased the copper weight still by 52%. The refrigerant volume is down by 51%, so we haven't lost either one of those benefits, but we have a coil that's in a much smaller footprint. And there's a lot of things you can do system design-wise to take advantage of that. The last design option may be, what if I don't want to change my footprint, or I don't need to change the footprint? Let's keep the footprint the same of the coil and increase the performance. So we'll go back to our 5mm coil. And we'll just do some selections here to get us back to the coil at 36-inch fin height. Excuse me, we lost a little bit of data there. And our 60-inch fin length. And this particular coil is going to be 1.5 circuited. So let's just analyze that real quickly. It tells me I need 5.97 rows. What I've done now, however, the big difference is this. My target is to get more performance, so I'm increasing my BTU required from 198,000 up to 240,000. Same physical space. And to do that, there's a lot of ways you could do it, but the way we're going to do it for this analysis is increase the airflow to 12,000 CFM. while keeping the air friction the same. Big thing we want to look at there is I don't want to put more air friction in the system. So let's just take a quick look. We'll analyze our 6-row coil here, calculate that out, and let's just jump over to the schedule. We'll show you all 4 coils together here. So there's the 4 coils we've been looking at. And now here's our increased performance with the same face area coil at the bottom. Today's 5/8 or 3/8 coil at the top. We've increased our capacity by 20% while keeping the same fin side air friction. We do need to account for an increased refrigerant pressure drop in the system, but it is you're running a greater mass flow of refrigerant to the system. But we still have benefits in the coil weight. Coil is still 14% less than the original coil, 31% less refrigerant, and the copper weight is down by 29%. So you can see that there are significant benefits. We've only shown you a few of the ways you may choose to use a 5mm product in your design. There are countless ways that you can. Because of the time we have, we can't show you all of them, but do let me show you a few things. I mentioned that the program is very flexible. So one of the things you may want to do, Matt showed you some pictures there at the beginning. The 5mm product is available in copper fin, so you can model that as copper fin here in the program. The program will automatically show you the thicknesses that's available in, and that is something we shipped our first copper coils just last week. The program will also allow you to do other size tubes, so you can see the tube options here. And the format that we're in on this particular screen is what we call our summary screen. If for those of you who are doing selections regularly, you'll find that this is an easy in and out one screen shot. We also can run this in a guided mode. To get to our guided mode, I'll just minimize this. You can see the different types of coils that are available. We've been working today on the condenser coil. The guided mode, we'll just click this big silver arrow. You can see the performance data will be put in here. On the next screen, we'll begin to see the bubbles of guiding us through selecting our material. So if we want to use our 5mm, we can select that here. You can see we have the 5mm on up to 1 inch. Each of these, as I click the tube size, will show you the pattern of the tube arrangement, if it's staggered or if it's in line. Then your different enhancements that are available. Tubes similarly. For the 5mm product, that's currently available just in copper. For our other materials or other tube sizes, we'll have carbon, copper, nickel, stainless, and that's all to really service the industrial and commercial markets that we serve. There are a lot of other reports. A coil design selection report, a coil design will allow you to see a brief sketch of the coil. And we would just encourage you after the webinar is finished to go back to our website, download the software, and we have a full staff of application engineers that can guide you through on how to use the software to best address the applications that you have. Thanks for your time today, and I'll turn it back to Matt.
Thanks, Louis. So as you can see, we're really excited about this product. It is, Louis demonstrated very clearly its power in larger condensers and multi-rows, and it's a copper product at the end of the day. So we have got a lot of flexibility with what we can do with it. And while today we don't have the opportunity to walk you through the other selections, you can see from looking at the software that we can produce evaporator coils. We can produce coils with copper fins. We can produce coils in formed shapes. We can produce coils of all different shapes and sizes and compact designs. And really what we found as we've worked with customers to deploy this it's really about doing something they can't do today. Meet an efficiency point they can't quite make, fit into a space they can't quite achieve, reach a depth or level of performance that they can't quite reach, or reduce a refrigerant charge. Those have been the most, I think, exciting parts as we've worked with different customers and their goals with this product. A couple other things to point out. Louis talked about the refrigerant charge, and I just wanted to expand on that for a moment. Geometry is in our favor, and this is just simple math of geometry of when we move from a 3/8 to a 5 millimeter, our area has, our primary surface area has reduced 48%, but our volume has reduced 72%. Now, if you recall, Louis mentioned 50% plus refrigerant reduction charges. Well, how do we get there? Again, it's the heat transfer coefficients. So when you combined geometry in our favor with better coefficients, that's when we see those really powerful reductions. When does this apply? Customers looking at propane as a refrigerant, really important, really important. Another interesting attribute, in addition to the performance, the heat transfer performance attributes, is that just the material strength benefits are unique as we move into smaller and smaller diameter tubing. What you see here is actual values just shown in a relative comparison of 4 different copper tube diameters, 5 millimeter on up through 1/2 inch, and the wall thickness that would be required to meet a 600 PSIG rating. And just the material properties and the hoop stresses are in our favor in that 50% wall thickness, 50% less wall is required to achieve those same strength ratings. Now, you may not choose to design in that fashion, but again, it is in your favor, and is that much more flexibility of choice in design to reach those high pressures. When might you do that? Again, higher pressure refrigerants, 410A, CO2 applications. We're finding that MicroGroove 5 millimeter is an excellent fit for challenges with higher pressures. But you know, the main message of today's webinar is moving beyond residential applications, in that MicroGroove coils are available today. The Copper Association has done a great job leading the way in publicizing this technology. It's moved beyond research. And so as customers review, how might I use this in my equipment? How might I apply this in something new I'm designing, or a cost reduction target I'm trying to achieve? There's lots of different on-ramps, whether it just be working on a primary selection and using the enterprise software that Louis showed you today, or working with an engineer, whether it's moving beyond that and doing controlled testing, we have the ability to do that, or rapid prototypes. We have some customers who say, forget the lab, I just want to try it. Let me put it in and see what it does. Prove it to me. So rapid prototypes are available, but I think most importantly, this product is available for commercial and industrial applications in volume production today, and we're seeing broad adoption. We're excited about it. The enterprise selection software that Louis walked you through is available. We make this available for free to all Super Radiator customers. You can get it through our website. This is the direct URL where you can go and copy and paste that into your browser. Again, all these materials will be available following the webinar. Or you can go to the Super Radiator website under the Resources tab and follow the instructions there to download and validate the use. So, and again, the software is not just for the MicroGroove product that we're talking about today. That's the full suite and range of capabilities that you saw that Louis quickly showed and highlighted. With that, that's the end of our prepared remarks today, and I'm happy to hand it back to Kyle.
All right, thanks for a great presentation. You guys gave a lot of really good information. We do have some questions that we'll ask you guys. I want to remind everyone listening in that there's still time to submit questions. We'll get to as many as we can here. The first one is, you have talked about less metal, but do the coils themselves actually cost less?
That's a great one, Kyle. The coils we've been discussing today and highlighting today, the condenser coils in particular, in many and most cases, there is a considerable cost savings in the unit cost of the coil itself. Just the metal reductions that we're talking about are significant enough. But it is important to know that with 5mm coils, sometimes the circuiting can be more complex. There are more circuits. The tubing can be more expensive. So there is an offset to some of that reduction. Also, I'd say that the size of the coil, as we saw a larger one here today, a 36 by 60 4-row. As you move to a smaller coil, say a 12 by 12, the amount of metal reduced and saved, the absolute amount, is reduced. And so sometimes that may not be enough to offset some of that increased production circuiting. And you have to look at other elements of your unit to see if you're getting the savings in either unit costs or cost of refrigerant. But I would say again that what we found in working with customers, the cost savings are nice, and we are seeing unit cost savings. But more so, it's about doing something they can't do with the product they have today. It's usually hitting a SEER rating, getting into a smaller space, meeting a weight requirement, reducing refrigerant charge. That's what we're really seeing as the driver. Although in some cases we're getting some cost reduction too, which is nice.
The next one up here, what is the maximum fin spacing you can get with 5mm?
It's going to vary depending on the thickness of the material. The dye has been proven higher than the numbers that we are currently publishing, but on a day-in, day-out basis, anywhere from 22 to 25 fins per inch is what we're seeing.
Alrighty. Next one up, is the 5mm product only offered with groove tubing?
No, the grooving is an important benefit, and I think John highlighted how the grooving can increase heat transfer performance, particularly for refrigerant. But we do have smooth wall tubing available, and it does lend itself to certain applications, water applications. You know, again, we've been focusing really heavily on refrigerant applications, but for water coils, particularly clean water coils, you have to worry about fouling otherwise. A smooth tube may be most beneficial.
Next question is from Karam, I believe. Are there any concerns with refrigeration velocity in the 5mm coil?
It's a great question, and it gets to, you have the same concerns with the 5mm and refrigerant velocity as you would with any other tube diameter. And for that reason, what we find with 5mm is that ultimately you're trying to get the same amount of refrigerant, or in the case of a water coil, through the coil as if it were another tube size. So what ends up happening is we have more circuits to the coil than in, say, a 3/8 coil. So what we're doing is keeping the refrigerant velocity approximately the same as what you would see in a 3/8 coil.
All righty. Next one up here is, what is the largest coil you can manufacture with 5mm copper tubing?
I'll take that one. And I guess I would answer that in two ways. Large being physical size or capacity. But for physical size, we've designed and built coils up to over 100 inches long using the 5mm diameter tubing. It starts to look like a long piece of spaghetti, but it does work. We've developed the techniques and practices to do that. There really is no limit on the depth of rows. That's proven to be a very nice advantage. Where when you're looking at other technologies, say a microchannel, where sometimes depth has become a problem, there is no depth of rows limitation in manufacturing these coils. So we have confidence we can build them over larger than 100 inches. What we found, though, is that manufacturing capabilities are not proving to be the limitation. Really, it becomes the pressure drop and the circuiting management is proven to be the limitation. If I were to answer it then in the largest in terms of capacity, certainly we've designed and built units with, I think, a 45 or 50 ton rating, and we see no reason why we can't go beyond that.
Okay. This next question up here is from Ken. What industries are adapting MicroGroove?
Well, John touched that early on in his in the beginning of his presentation, but we're at Super Radiator, we service many different industries, and without getting specific into our customers, I think generically what you saw there, certainly different types of commercial air handling units, some of the refrigerated display case applications, anywhere that you can think of where you're using heat exchangers and some of these more challenging beyond just your residential or light commercial application.
Robert is next up here. What patterns would you use for water?
So the pattern that we would use would be a staggered tube arrangement. The particular pattern that we're using, that we demonstrated in the software demonstration for the condenser coil, would be entirely appropriate for water coil as well, and we in fact have some coils in application for that right now.
Okay. Next one here is Walter. Have you considered using 5mm tubes for heat pipes?
I guess to answer that fairly, have we considered it? We absolutely have. But remember who we are as a company. We're a manufacturer. We're looking for the right partner to develop that product with us and see how it performs in that application. So great question, Walter.
Okay. And here's one from Bill. Any tube expansion issues for small diameter tubing?
Certainly, we spent a lot of time and energy developing the manufacturing techniques, and we didn't really get into that in the in today's webinar. Baroque did I think a really nice job talking about the different challenges in each of the dimensions of manufacturing these coils. And so we've certainly come a long way on the learning curve for that. We're happy with the way that we're doing it. It's proven to be very cost effective, and we like the performance that we're achieving. But most of our manufacturing techniques are proprietary in form.
I would recommend, for more information about the manufacturing issues, to go and pull up the archived webinar with Baroque from last year, and there's a lot of information there.
Okay, great. Next question has you guys looking into a crystal ball a little bit. Do you think that coils with 3/8 tubes will eventually not be manufactured anymore?
That's a really interesting question, because at the same time that we're talking about 5mm coils, we also have many customers who are using 1-inch and even 2-inch tubes. The fact of the matter is we don't know. I suspect that no, there will always be a market for some application, especially, this is not a panacea product that it replaces every application, because there are some systems, especially larger systems, that you absolutely have to have the larger tube diameter to get the amount of flow, refrigerant flow, oil flow, whatever it is, into the coil, and you've got to have that larger tube. So, great question, but no.
All right, this one's from Mark here. All other components remain the same, fan, compressor, etc. What would you say would be the increase in ER HSPF rating using your MicroGroove tube coils to maximize the energy efficiency?
Yeah, that's a question that it really gets down to the particular system. Because we don't manufacture the entire system, it's very difficult for us to manufacture that, or to answer that question directly. However, I can relate to you, we've had at least 2 cases of customers who are facing energy efficiency ratings from government entities, in which with their current 3/8 tube product, they're not able to meet the required efficiencies. Using the 5mm, they've been able to pick up the efficiency of the product, and in one case, it looks like they're able to continue to offer a product that would have otherwise been obsoleted.
All righty, thanks. Well, it seems like we've run out of time, gang, but I really appreciate the information. You gave an absolutely fantastic presentation. This concludes today's webinar, so please join me in thanking our presenters as well as our sponsor, MicroGroove. As you exit today's webinar, please take a couple minutes to complete our survey. We strongly welcome your detailed comments to help us serve you better. If you have any additional questions or comments, please don't hesitate me at Kyle Gargaro at achrnews.com. And please visit webinars.achrnews.com for the archive of this presentation as well as information about our upcoming events. We appreciate your time, everybody, and hope you have found this webinar to be a valuable experience.